through the entrance ticket so that we started with, so these here. Thank you.
Let me finish my test one. Someone smells like foot now.
You what?
Let me finish my test one because it's just one of them.
Okay.
So.
So if we look at this first problem here, no. Yeah. On a standardized test, the score starts at 100. For each correct answer, the overall score is increased by 5. For each incorrect answer, it's decreased by 2. If a question is not answered, it is counted incorrect. Shelley takes the test and finishes all the questions. The number of questions she answered correctly is equal to 4 times the number of incorrect answers plus 5. Her overall score is 395. How many questions did she get correct? So we're saying that the number of correct is equal to 4 times the number of incorrect plus 5. And the overall score, because they get how many for correct answers? Because 5 for each correct answer, and they minus 2 for each incorrect. And how many did she get total? $0.95. So what we could do is we could plug this in for C and solve that way, which would tell us that we have 5 times 4i plus 5 minus 2i is equal to 395. 5 times 4i is 20i plus 25 minus 2i equals 395. Well, 20 minus 2i is, I'm running out of room, 18i. Plus 25 is equal to 395. We can subtract 25 from both sides. 395 minus 25 is 370 is equal to 18i. And if we divide both sides by 18, 18 goes into 37, not 37, I mean not 18, because this should be what? 20. Which here would be 117. No, I had that right. It was 18. Well, I'm second guessing myself on that. Erase. Yep, 65. Let me erase it back. So, is 18. So we just need to do 370 divided by 18. $370. What am I missing? Because for each correct answer is 4 times the number correct. 20 plus 5, yeah. 25 minus 5. Oh, because where did the test start at? So this here actually is supposed to have plus 100. So this should be 125 which would take it down to 270. Which would give us 15 for the incorrect. But correct number is 4 times incorrect plus 5. So 4 times 15 plus 5. 4 times 15 is 60. And that's how we got 65. All right, let's look at this next one here. Now, the table belongs to the prices, kind of the overall prices for short and long hair for color and perm. Over the course of 1 week, Celeste, one of the stylists, collected $840 for coloring hair. For coloring the hair of 20 different clients, not counting tips, how many of those clients had long hair? So we're looking at this here. We don't care about perms. But we know that $30 for short plus $50 for the long hair gave her how much money? $840. Well, how many people came into the salon? 20. So the number of short plus the number of long should equal 20, yes? Now there's different ways we can go about it. One of them that we can do is say, well, we could start at the middle, say 8. So if we said 8 for long hair came in, how many would it be for short? 12, because for them to be equal to 20, short would have to be 12 if 8 was for long, yes? We can check it in this equation up here. We could say 30 times 12 plus 50 times 8 and see what this gives us. Well, 30 times 12 is going to be 360. 8 times 50 is 400, which is 760. Is that what we wanted? Is that the price we wanted? Because what is it supposed to be? 840. So that's not 840, which means that the overall price for this here is it's not 8 for long. So $8 for long doesn't work. What's another guess we could put? 12. So if we say 12 for long, the number of short is 8. So we can do 30 times 8 plus 50 times 12. And again, we could type this into the calculator and let the calculator do it for us. 30 times 8 is going to be 240. 5 times 50 times 12 will have 0. 600, 240 plus 600 is 840. Is that what we wanted? So the correct answer is 12. Because the other way we can do it is solve it as a system of equation, get one of the variables equal and cancel it out. Or we can set this up as a matrix. And have it as 30, 50, 840, 1, 1, 20. And do our RREF like we did in Algebra 2. And it would give us the answer. $30, $50, $840. So we can go second matrix over to edit, and this is a 2 by 3. So we had 20, 50, 840, 1, 1, 20. Quit second matrix. Go over to math. RREF, second matrix A. Because I think it was it 30? I don't think it was 20. Yeah, it was 30 for long here, not. So second matrix. Edit. Because this should have been 30. Which would have told us that we have 8 for long, or 8 for short and 12 for long. So we could have solved it that way. Tad's sister, Tina, asks him how old he is. Tad tells her that if she squared his age and subtracted 3 times his age, the result is 40. So x squared minus 3x is equal to 40. So the two ways we can do this is, one, we can get this equal to 0. Say x squared minus 3x minus 40 is equal to 0. And we can factor it. Our two sets of parentheses with 3 lines. Since the third term is negative, our signs are opposite, plus and minus. The factors of x squared are and x. Now the factors of 40 that we have are 1 and 40, 2 and 20, 4 and 10, 5 and 8. If we check this, x times negative 8 is going to be negative 8x. Plus 5x is negative 3x. What did we want? So that works. So we can say x plus 5 is 0, x minus 8 is. So x is negative 5 at 8, or x is equal to 8. Well, his age can't be negative 5, so it has to be 8. Now, another way we can do this is we can pick a number. We can say start at 8 and plug 8 squared minus 3 times 8 and plug it in the calculator to see if we get 40. If we don't, if it's too small, we can go bigger. If it's too big, because if it's too small, we can pick bigger numbers. If it's too big, we can pick smaller. Well, 8 squared is 64. 3 times 8 is 24. And we get this here. So we're translating words into mathematical expressions and solving systems of equations. So the first thing we want to check is kind of some of these terms here. So the first one is value. Well, if we're talking about a value, we're talking about a number or measurement as some type of term. An expression, okay, is a group of numbers, symbols, and operations to indicate a value. So we could say 3x cubed. This would be an expression. Where you say 3x cubed plus 7x. An equation is two mathematical expressions set equal to each other. We're talking about something being equal when we're talking about an equation. Coefficients are just the numbers next to a variable. A coefficient is a number in front of a variable. And combining like terms is in an equation the process of simplifying, adding the things that are same variables, same expressions together. Now the first thing, or kind of the last thing we'll end up doing in here, is this activity in your note sheet on 3.31. So go on and work that first one out. What is the sum of 2 and 5? How would we write that out? So y equals negative x squared plus 2x plus 3. Graph. So we're seeing where it crosses the x-axis. So we do have two spots. Okay, so the second graph, we're looking where the y is 0, so one of them is, and the other is 3. X is equal to -1, comma, 3. Yes. So, the first one, what math operation do you think the words such as together and combine both translate to? So what would that be for the first one? Together, combine, what are we talking about? So the first one would be addition. What math operations do you think the words such as minus, without, less, difference, change translate to? The next one. What do you think the words or operations do you think words such as times, product, each, per, or of translates to? Yes. What math operations do you think the words such as divide into, split between, or among, doled out, divvied up? The next one. What symbol do the words equal to is the same as translates to? Yeah. Equal sign. And the last one, what do you think the words what, unknown, a number are? Yeah. Something that we're solving for. Because if we're solving for something, we're looking for a variable. So looking at these next few, so we want to translate this. So we're not going to solve, but we're just going to translate it from words into a statement. So if we're talking about what is the sum of 2 and 5? So what, if we're looking for, would be a what? Because is our equal, yes? What? So x is equal to 2 plus 5. Because what is the sum of 2 plus 5? So x is equal to 2 plus 5. Okay. Let's look at the next one. Together, 2 hamburgers and 1 drink cost $15. Okay, so 2H would represent hamburgers. So what would we do to represent drinks? Yeah, so 2H then. Now, we don't have to use H and D. We could have said 2X plus Y equals 15. That would have been the same thing. But we can use H and D to represent hamburgers and drinks. What is 15% of 100? So this is the last one we'll do. So what is, would be our x, yes? Equals 15 as a decimal is 0.15 times 100. So we'll stop here for